Good afternoon. I think it was a very insightful and a very impressive keynote speech with a lot of examples. So to start with, I would like to ask a question to President Elver. As you also, in addition to Taiwan, you serve in, for example, in China, in Vietnam, and you have this future of manufacturing truck around the Taiwan. But in Taiwan, on the other hand, we have high-tech manufacturing. We also have different segments. So in your observation, how the Industry 4.0, especially Siemens technology, can help Taiwan's industry in different segments?
Well, there is not let's say, single solution for all industries. This is, I think, valid also in other areas. And as I have shared with you a couple of examples from different industries, we are having customers in the car industry, in petrochemical industry, but also customers in semiconductor industry. And of course, we have to see, talk, and understand the specifics in the relevant manufacturing area, and then also together with the experts and customers, think of how can things be designed and develop in a way that the manufacturing process can be optimized. At the end, you remember one of my first slides, we want to increase efficiency, we want to be faster, and we want to be flexible. And that is something which we have to also consider from manufacturing to manufacturing, from one sector to another sector. And I'm repeating, there is not one single solution, so this must be discussed and also designed specifically.
Okay, so if I ask this way, for example, you use automobile as example, and using that twin model, that you have digital model to help design and development. And would that type of twin model digital manufacturing may be more domain specific, so that it will take more time to work with specific industry segment or domain to develop it? Can you give some example that you have done maybe in Taiwan or Asia that develops this type of twin model? Thank you.
Yes, we have, of course, we are talking and also working with different customers. We have last year signed an MOU with one of our customers here in August this year. I have to correct myself. Signed an MOU with one of our customers. I think it was public, I can also mention the name, Inventec, right? This is an original design manufacturer for high-tech products. We have signed an agreement to support them, and they will integrate into their future planning our systems, our PLM system. I have shown a couple of examples and areas, and to see how they can improve their planning on one hand, product planning, manufacturing design and planning, and make things in a more efficient way. So there are examples we're working and supporting the customers to get prepared, let's say, for the future of manufacturing.
Okay, thank you. Then Mr. Gollapudi, you yourself actually is also a researcher, and you also manage especially the semiconductor team of CYIENT to help even some of Taiwanese companies like Global Unit Chips and the MediaTek. Can you use, maybe if it is okay to use the company also in Taiwan as an example, how CYIENT service or your technology, especially in light of this cloud computing, Internet of Things, big data, that you can help Taiwan's industry? Thank you.
Yes, thank you very much. And in the VLSI chip design today, there is a lot of system integration is happening, i.e. a lot of whatever we have seen in the past as a lot of subsystems, as discrete components. We are trying to put all those things back into a single chip or a multi-chip solution. The helping thing that is happening is the advanced process nodes, which is the companies like the TSMC, UMC, Global Foundries. We are looking at the current mainstream technology as the 14 nanometer, but we are already developing the IP in 10 nanometers, and the next process node is going to be the 7 nanometers. With this industrial revolution or the integration with the IoT, you name it, whatever the vertical field that we look at, it may be medical technology where you have the miniaturization is going on, and the semiconductors are playing a very critical role in actually making these vertical markets to really be playing the industrial revolution of 4.0 or even the next generation. So with that, what is that we are doing at CYIENT as an organization? There are three ways that we are looking at it. Is purely looking at it as service side of the equation, providing a solution, and also providing a proof of concept at a system level. These are the three levels of migration that we are looking at to support the companies like MediaTek. It may be other companies like GUC, where they are going to be playing their services to provide the system solutions. So CYIENT is going to be playing a very critical role in that area. And we are gearing up in producing engineers that think that way, that can act that way, and produce the next generation of requirements. So that's where CYIENT is focusing on.
Yeah. Frankly, I know semiconductor industry quite well, and these two customers of yours are one of the largest fabless company, MediaTek in Taiwan, and Global Unit Chip is like one of the largest design service company in Taiwan, and they both still use your company service. And on the other hand, the semiconductor industry probably quite different from other industry in Taiwan or maybe other industry in the world. So when we talk about this future of manufacturing, can you also use your observation both in your position in CYIENT? You can observe semiconductor industry as well as other industry. So can you use that to share the observation about the difference about what's ongoing in semiconductor industry versus what is being proposed for Industry 4.0 or in other segments?
So this is like a push and a pull type of a thing. Some of these things are going to happen not by choice. If you don't play and be competitive and be prepared to address some of the events that are happening in the industry, you're not going to exist. We have seen that happen over and over. That preparedness to really understand where the technology is migrating and how we are going to be prepared to work with the organizations that are growing, not only looking at an organization, but looking at different geos, is a very critical thing for anybody to succeed in this flat world. With that, our focus on the semiconductor industry used to be primarily the North America, and we have identified the Asia Pac as the next growth few years ago, and that's why we made a lot of investments, and we have opened offices in Japan, Taiwan, and very critical customers are here. So with that, it's not by choice. We have to be doing this, and we are getting prepared to address that particular growth of the 4.0 and beyond.
Okay, thank you. Mr. Izzo, STMicro is a world-leading provider for a lot of key components, especially in this Internet of Things and also automobile, etc. From your vision, how this IoT will change our world? Because we talk about Industry 4.0, we talk about design. How about Internet of Things? What is your vision? Thank you.
First of all, I would like to add to what Professor Gollapudi said, the semiconductor industry is the most similar to a 4.0 type of industry from the manufacturing point of view. We know that the manufacturing process of the semiconductors is split in 4 blocks. Right? It's foundry, EWS, assembly, and testing. Okay, final test. And these 4 steps can be done in different locations in the world, or in different organizations in the world, or in 4 different companies in the world, okay? And they have all to be connected and be in communication so that the product arrives on time to the customer. So today, in principle, it's the form of industry already operating according to the criteria of the 4.0. My company is working on this. However, this industry is very, and the flow of the operations is so critically complicated and complex that if you do not have a 4.0 type of logistics, you create a lot of delinquencies, what are called delinquencies in terms of deliveries, okay? So just in time, RD delinquencies, CD delinquencies are critical parameters which have to be kept under control every moment, because if you do not have a logistic 4.0, you cannot have a very effective industry 4.0. Having said so, what is the future of IoT? It's a very, very difficult question, okay? I believe that, as we said, everything will be smart. But if you go through the dictionary and you check the definition of smart, under that word there is smart is cunning, is handsome, is dangerous, like Erdal. Is effective. So there are many different characteristics of smart people and therefore smart things, okay? So in my point of view, in the future, more than smart objects, there will be products which will reply to 2 key words. The keywords will be sensibility and verticality. Sensibility to human needs. We have to understand not what products to make, what people need, right? And where. Right? So if we address the problem of people needs in Taiwan, they may be different from the people of, needs of people in Africa. They need drinking water, for example. Here we need something else, right? So sensibility to human needs is the centrality of the theme of IoT, and the second point is verticality. Once we understand what is needed, we have to understand the vertical segment, okay? I give you an example. Lighting is getting smarter. Hospital beds are getting smarter. Cars are getting smarter. Meters for electricity usage are getting smarter. But each of these applications are vertical segments, okay, which involve a huge amount of efforts and therefore very complex ecosystems. No? You need big data management, you need cloud computing with server management, you need software and application software, you need hardware, you need technology steps. It's a very, very complicated story for each vertical and cannot be done by one single company, but it has to be done by a synergetic effort of many, many different organizations. So, therefore, sensibility and verticality. Now, when we come to the specific problem of Industry 4.0 and IoT on Industry 4.0, I believe that this will take probably 20 years, 30 years to come to a form of stable and effective and efficient system. No? Not every company is like Siemens. No? There are different situations in different places of the world. However, I believe that the landing point or the real Industry 4.0 will happen when 3D printing and IoT will converge and will be effective, okay? And when I mean IoT, I mean, by IoT, I mean connected robots. Erdal has shown many robots making 6 movements, okay? These are 6 motor robots. They are called anthropomorphous, similar to humanoids robots, but not yet not yet the same as humanoids, as opposed to the previous and historic robots called Cartesian robots, okay? 1 motor, 2 movements, okay? So we are in this transition from Cartesian robots to anthropomorphous robots, okay? Now this has to go through many different steps. The anthropomorphous robots are still standing. So the 2-dimensional robots are in a cage. The 6-movement robots are on a pedestal, but not yet moving. They are not yet collaborative robots. Like the first step of collaborative robots is the iRobot cleaning the floor, right? So when we have now robots moving around, picking objects, remembering what to do, making decisions in new scenarios in a connected way with collaboration of 3D printer, that will be Industry 4.0. To go to that level, it requires many steps, not only in technologies, but also in new materials. To realize a collaborative robot, you have to embed the tactile capability. Therefore, the force sensing, right? The 3D vision, the ability to make decisions, the environmental parameters have to be controlled, the color recognition and so on. So I believe that a lot of efforts and steps have to be made in this direction, and they are underway. And when this happens, the car industry will not be the only one absorbing this ability to produce better products in a very efficient and fast way. But I believe the pharmaceutical industry will be even faster. The medical industry will be more receptive, right? Think about the blood check clinics, right? Blood test clinics, they already use robots. Think about pharmacies, right? When you go to a pharmacy in Europe or you get medicine falling out of the sky, they are managed by robots. Think about the food industry. If you have to buy the lasagna from a supermarket, that is not made by a chef. That is made by a robot. So the applications will be huge, tremendous, and will require a lot of different machines with different capability and power of execution. Therefore, I believe that things are now starting, and technologies are underway. There are great companies like Siemens doing a lot of different products. There are a lot of other companies like mine and those around here today trying. And I believe, as I said in the beginning, the next 10, 15 years will be busy.
Yeah. Mr. Izzo, you also, as a Vice President of Semi-Taiwan, and Semi-Taiwan actually just celebrated 20th anniversary in Taipei a few weeks ago. From your observation, because you were saying that next 15 years will be very busy. So what will be your observation of this ecosystem in Taiwan, and what will be your suggestions?
The Taiwanese industry and the Taiwanese government have to make very important and urgent decisions. I started my career, and I have spent most of my life here in Taiwan, okay? In Taiwan, you do not, if you are a foreigner, you are brought to Taiwan by your law, okay? Your heart, and therefore, once you follow it, you settle here and you don't move anymore, okay? So, but that's not a good reason. Taiwan has to change from this point of view, okay? It has to become international, right? You cannot attract foreigners because they fall in love with the Taiwanese lady. No, foreigners have to come here because Taiwan is a choice, as it is Singapore, as it is Hong Kong, as it is Shanghai, as it is New York. Has to be a choice, and I believe these are there are the characteristics and the elements in Taiwan to do so, to attract foreigners, and this has to be facilitated by government, okay? With Erdal, we are directors of board of the European Chamber of Commerce. This is one thing we promote and propose and remind through our position papers to the government here in Taiwan. This choice number one, or responsibility number one, is political. Responsibility number two is industrial. In the past 30 years, the Taiwanese model has not changed. It's still ODM or OEM. Right? There are no brand companies in Taiwan, except for one or two. There are no brand companies. It's always doing something for somebody else. That means no R&D investments. Okay, so this has to be resolved with priority, okay, in priority. Third point, which is equally important, as I said, in the verticality, right, there is a concurrence of many organizations. Taiwan is excellent in something, especially in execution, especially in execution in manufacturing. I believe Taiwan ends that to the extreme level. Think about Foxconn, 1.5 million people, okay? It's unbelievable, okay? So that is managed properly by many companies. Can be Foxconn, but also Tatong, okay? Can be Delta Electronics or can be Wistron, right? Many companies can manage the science of manufacturing up to the global level, but the creativity is not yet there. So therefore, building up alliances, cooperation programs with external companies, external organizations, can be Indian, can be Italian, can be German, can be Turkish, can be American, can be whatever, but international cooperation is the third building block of the future. I believe there are so many, I would say, ringing the bells here in Taiwan. It's time that we all in this industry move in these three priority directions.
Thank you very much. So maybe I would like to open the floor to the audience. If someone want to ask a question, or I actually have a lot of questions I want to ask, but before that, I would like to invite if there are some questions to the panelists. Maybe I will just firstly continue from Elver. There was a question you asked about how many jobs from manufacturing. The answer was about 2.2, if I remember correctly. But talking about the job associated with manufacturing, of course, it will be affected by the way of manufacturing. If we move on and continue to Industry 4.0, a lot of robots doing the manufacturing job, where the job related to manufacturing still be that many. And of course, manufacturing is still very critical for economic, for GDP. But as we move on for automation, for intelligent manufacturing, maybe it will create some impact to the society or the community. Of course, in Germany, you have very strong unions, so you must have think about that. Can you share your observation or your thinking about the future when we keep moving this way? Thank you.
I think we have also strong unions here in Taiwan, not only in Germany. And I try to emphasize also the importance of human resources in my examples. We will not have manufacturing sites which is working without human beings. This will not work. But the roles will change. As I have highlighted, we kept the number of people working in that factory since years. We didn't reduce. I mean, from logical point of view, if you do more automation and use more software, then you need less people. We could theoretically, from logical point of view, say we had to reduce the headcounts or people working in that factory, but we didn't. And so that is, I think, important, and that's also why I have highlighted at the very end, the education, training of people will play an important role. We will have new roles. We will learn new things and have to deal with new type of tasks. designing those systems, designing the rules for interaction, and ensuring that those systems are working in that way how we want them to work. So therefore, I personally don't believe, and also our experience in Germany shows that we will not reduce the workforce. We might keep it on that level where we are, but we need to train our people, give them new skills, new competencies to deal with the technologies coming into the manufacturing, and also design the future together with us. So that's my view.
And I was working with Taiwan's industry a lot of time. Most of Taiwan's company, they tend to be more focused on how payback, return of investment. I mean, for CYIENT, you basically, your service is more like your brain power or your technology service. It's not really tangible equipment or software. How do you communicate with your customer or justify the value of your service? Can you share?
So wherever there is a need, that is what creates the innovation kind of starts. And if you look at the overall service industry on the development of chip design and the need in Taiwan, what we have in India is the fundamental brain power, where we are actually producing quite a few engineers, and they're all very well trained in these advanced technologies. That is where we have an advantage. And we also have an advantage of the language, which is speaking English. And we are kind of taking an advantage of that particular aspect of it, whereby we can work with, where there is a need. Even though Taiwan, we still have certain language barriers, but just the fact that they are working on such an advanced technologies, and we are able to supply the need where the understanding of the technology being able to implement. So that particular aspect of it is where we are taking advantage, and we are able to actually address the market space with that technical competency, or the edge that we have is what is making us participate in these markets.
I would like to mention that Tsinghua University, National Tsinghua University in Hsinchu, we actually have largest population of Indian students and the scholars in our university. One of the reasons we almost 10 years ago, we collaborate with TSMC to recruit talents from India. Whether they want to study, they can go to Tsinghua University, or they can work in TSMC. We actually celebrate Indian New Year in our campus quite often. So whenever you are staying in Taiwan, you're welcome to join us. And now I want to ask the same question to Elver too, because this type of investment for Industry 4.0, even myself, sometimes people will try to ask us, of course they pay much less, but they still want justify, because this is more like a solution, or not just your hardware or software. Sometimes it is analytics solutions such as big data or intelligent manufacturing. So in Siemens, when you try to sell or try to propose your solution into Taiwan's industry, when they ask how much do I need to invest, and how can I pay back or return of this investment, how do you communicate with your potential customer?
Okay, it depends where you're looking at. If we talk about Industry 4.0, in fact, it's future investment, and certain investments needs to be done in advance to reap the fruits later. For us, it's important to show, and also the importance of changing, importance of doing things faster, more efficient, more flexible. I mean, we are in a competition in every sector, in nearly every area. If you are not efficient, if you don't save energy, if you don't run things more cost efficient, then your cost will increase, and you will be not able to compete with your own competitors. Now I'm talking about my own own customer, right? Or if you're not able to be faster in responding in product cycles. You know, we are talking about time to market. If I spend too much time, then others are doing faster, so then I will lose. I think there are a lot of reasons to invest. And Giuseppe was also nicely explaining, important is now to collaborate, to cooperate, to learn, and also improve. And also important to be ready to change, and sometimes change needs investments. There's a very nice statement from Charles Darwin. This is the famous guy. Yes, he said, it's not the strongest, not the fastest, not the fittest will survive. Only those who are able to change and adapt will survive. And that is something which we have to consider, and this is also valid for many industries. If you're not able to change, if you're not able to adapt, you will die. I always give nice example from my own company. I mean, not my, yes, I'm also owner of Siemens, I have shares. So, not the majority, but, so, if I look back, I joined Siemens 30 years, more than 30 years ago. If I look the portfolio we had at that time, and look the portfolio we are having today. We're talking about, you know, future of manufacturing, many things which we didn't talk at that time. So we changed over time our portfolio and adapted to the needs of the markets and to our core competencies. The portfolio has changed more than 60–70%. Many people still think of mobiles and telecommunication if you talk about Siemens. We don't do it anymore. We changed. We adapted because we see, hey, there are others who can do better, fine, let them do it, we do other things, which the others cannot do. And this is again an example. If you want to survive, you have to adapt, you have to change, and this is also valid for many Taiwanese companies. If you think too much on money, on the capex, on investments, and don't change, one day it can be too late. Others will be faster in changing, faster in serving the customers, and this is something which we are also telling to our customers. And we, I mean, as European companies working here, we are here also to support, to contribute, but also earn money. You know, I want to help my customer that he's successful, and if he's successful, I will also be successful, because at the end, we all want to earn money, and it's, I think, a great win-win relationship. And this is also true, especially for Industry 4.0, to get prepared for the future for the manufacturing, and which is very important for Taiwan, because you have, you know, you're also a developed country, a lot of manufacturing is going on, a lot of key industries, and we need to also look at and adapt and change and be faster and be better.
Okay, Mr. Izzo, I would like to go back to your earlier sharing about semiconductor industry. You said that probably in semiconductor industry, some of manufacturing already close to Industry 4.0. However, some of maybe not. So in your observation, maybe not just use STMicro as example, probably just this industry, to share what is the missing part if this industry want to transform to the future manufacturing like Siemens models. What will be the critical gap to be filled?
I have no way to reply to you because I do not have enough experience in manufacturing. I'm a salesman, and I do not own Siemens. So no, I am in the sales organization, and therefore I do not have enough knowledge to reply to you. However, going around in Taiwan, we see a lot of different companies, and especially within SEMI. SEMI represents gathers a lot of semiconductor companies and semiconductor machinery companies, okay? And those machinery companies are primarily growing up very, very strong in the area of Taichung, central and southern Taiwan. And we visit a few of them as potential customers for us, though they are not very big, but very promising. And so today I believe that when I say that semiconductor industry is close to an industry 4.0 concept, I refer to the flow Erdal was showing, that you can split the blocks of manufacturing in many different parts, in many different phases, in many different steps, in many different locations in the world, and they are connected. If not by internet, they are connected by some means. My understanding and my knowledge is that the semiconductor industry is still from inside is still at the Cartesian type of robotics, and therefore not at the six motor type of assembly. And there is not much to expect in the wafer foundry, right? In the wafer fab, because the wafer fab is typically already automated. Okay, the EWS itself is a robot. You put testing programs, put wafers in, and they come out with inked. Okay, what is the next step is in the assembly. Okay, how the assembly can be, and that's what is more sensitive to manpower, and how can this be rationalized and made cheaper? That I don't know. I do not have enough experience from that point of view. Okay. So my statement, original statement, was more on the principle of Industry 4.0 than you know, there is a curious example. No, I joined a workshop, also Erdal was there not long ago, about digital companies. No? So there are three, with Korn Ferry, okay, there are three types of companies. No? One type are the pre-digital companies. Second type is the digital companies, and the third type is the post-digital companies. And no matter you are making digital products or not, you may be in the pre-digital stage, okay? Many semiconductor companies in their operations are in the pre-digital stage, okay? Not in the digital stage. And by that, I mean not only the manufacturing, also the way of operations.
Maybe I will give each of panelists some time before we close this panelist about your regional observation about this cloud, big data, Internet of Things. Maybe we start from that. Yes.
Sure. So this big data thing, the way that things are moving, I will make few comments with reference to the VLSI, the chip design. If we go back about 25 years ago, the storage was a pretty premium thing. Every time we did a chip, we have to go back, store the data back before we can start the new design. Nowadays, a terabyte is probably coming sub $10. The accessibility to the storage and also the complexity of the systems that we are trying to do, and we are generating more data, and this there is no actual inflection. As long as we bring the storage down to a very, very accessible area, we are going to be generating more data. And then out of all this data, what is the relevant data that you really need to store? 9 out of 10 times, if you are generating 10 terabytes of data, the relevant data that you really need to be storing is only probably 1 terabyte. That is the statistics that is out there. But the fear of what is that 9 terabytes that's sitting there, and it is all getting generated by multiple individuals, multiple programs. What if I need that? Right? It's like packing our garage, right? I may need that somewhere down the line, so we throw it because we have the space. The similar thing is happening in the big data, especially on the chip design side. A lot of the companies like the CAD tool vendors they are focusing on how do we optimize in generating this data so that it becomes manageable, storable, whereby we can actually access it down the line when we really need it. So that is the focus area that where we are going to be seeing on the data collection and the analytics, whereby when you really need it, how well we can access it and use that. So that's on the design side of it. Now you migrate it to the manufacturing side of it. Each fab, each wafer, each chip, there is so much data that gets generated. That's all getting stored somewhere. The problem is, as long as things are going extremely well, you really don't need that data. But when something did not go well, you really have to go back to that particular wafer, that particular die. So what has happened? Figuring it out, getting this particular data back and analyzing it, whereby we correlate to your original design. And it has to happen in a very timely fashion because some production line is stopping because something went bad. So from a data analytics side of it, from a VLSI design, combing through this, both from a timeline and the volume of data, is where the next focus is going to be. And CYIENT as an organization, we have acquired a company on the data analytics side. So whenever I get a chance to meet my colleagues and start talking, these are the areas that we kind of believe where there is a need for us to be able to be focusing on the analytics, whereby we actually can add value, both on the retrieval and what we should really store, the relevant data. That's where the future is going to be moving.
Thank you. Mr. Izzo.
He's doing one part of the job, we do another part, okay? Not everyone has to do the same job, otherwise we compete so severely that we lose the profit. No, one of the key challenges of IoT data, big data management is the first of all the volume of data and therefore the band. Yesterday we joined with some of my friends here joined the seminar with Ericsson on the 5G. 5G is the promise for the real IoT. Okay, there is no other promise on the volume in particular. And the latency. So they see the key parameters are the volume of data and latency, especially for actuation, remote actuation. Okay, it has to be, the latency has to be almost zero. Okay, so these are the key bottlenecks as we move forward into utilizing big data. From our point of view at STMicroelectronics, we look at these aspect from the security point of view. Okay, so ST is a global leader in secure microcontrollers, and so we keep investing in that area. I am sure that if today you start any service, you want to be a service provider in any kind of cloud activity, can be small or big. You have that. The first thing you have to do is to hire an army of anti-hackers. Okay, the first thing you have to do, and these have to work 24 hours a day, fighting with the hackers. You know, a war which is fought as a war. Okay, a digital war. And I believe the area of security is the area where we are making large investments today, and where we will keep investing more for the future. Okay.
In fact, Industry 4.0 describes nicely the vision where everything will be integrated. You remember the one slide? We have the horizontal integration of the value chain. We have the seamless integration of different steps, product design, production design. and the vertical integration of the production units. So that is in fact the vision, and we are talking in fact connecting everything. In the past, you know, there was a slogan connecting people. In future, we have to say connecting people with the machines via the cloud, using all the big data, smart data, and running things in a more efficient and efficient way. And for all this, of course, we need innovations. We need proper software tools, software design tools, and proper automation tools, which will help, of course, to run the product manufacturing in a totally different and efficient way than we are running today.
Thank you very much. Okay. Yeah, let's thank our three distinguished panelists, and let's conclude this panel discussion. Thank you very much.